Hi, I'm Ms. Fung. Today we're going to look at completing the square and turning points. So here we have x squared plus 6x. I've drawn it here so that you can visualize what we're doing. So x squared is a square with sides x. Here we have the length 6 and that side is x, so that bit makes 6x. So x squared plus 6x looks like that space there. What happens if we split this rectangle into two, so that instead of 6 over there we have only 3 there, and we move that piece down there? Pretend that it's a line. My program is being a bit funny today. We'll move that piece over there. Now we can complete this image here into a square that has the side 3. Remember, we chopped it in half. So we can complete this square by adding 3 times 3 is 9. We can add a 9 in there. So how do we complete this square or make it into a perfect square? We took the 6 and then we divided it by 2. Remember, we cut it into 2 and then we squared it to get 9. Now you can't just add a random value. If you add and subtract, then you haven't changed your expression. So whenever you do that, you also have to subtract the same value. So plus 9 minus 9. So now these three things here, or this one here, this part here, see with the blue line, makes a perfect squared. So that part there becomes x plus 3 squared, and now we have minus 9 on this side, so it doesn't change what we started with. So let's do example 1. Solve the equation by first completing the square. Here's the equation. So now say we have, see, same. So say we have x squared plus 6x and plus 7 doesn't complete the square. So we can complete the square by looking at this 6x and then adding the 6 divided by 2 squared, which is 9, and subtracting the same value. So this line here is exactly the same as this line here, except we've added and subtracted a 9, which is 0. So they're the same. Now, if we do that, then this section here is a perfect square, these first 3 terms. So these first 3 terms is x plus 3 squared. And then we are left with minus 9 plus 7 is minus 2. So now we have a perfect square and a minus 2. So it says solve, so we have to continue. So bring the 2 to the other side. So we have positive 2. Now square rooting, and we don't forget the plus and minus. And now bring the 3 to the other side, we have minus 3. So our solutions are positive square root of 2 minus 3 and negative square root of 2 minus 3. I've read them the wrong way around, but same answers. Example 2. 2x squared minus 3x minus 1 equals 0. This time we have a 2 in front of the x squared. So let's take the 2 out first. So now we have x squared, 3 over 2 because we took the 2 out, and 1 over 2 because we took the 2 out. Now we can complete the square. Remember, dividing the middle term or the term in front of x by 2 and then squaring it. So now we have the middle term is 3 over 2 divided by 2 is 3 over 4. And then squaring it, and then whatever we add to make our perfect square, we also have to subtract so that we haven't changed the question from the previous line. So I didn't write that 2 again because 2 times this factor equals 0. Clearly we can bring the 2 over the other side and not worry about it anymore. So we're only worried about the things inside this bracket. So now this part here is a perfect square of x minus, because there's a minus there, 3/4. 3 squared is 9 over 4 squared is 16. So 9 over 16. Then minus a half. A half converted to 16th is 8. So minus 9 minus 8 is minus 17 over 16. Bring it to the other side, we have positive 17 over 16. Now square rooting that. And square root of 16 is 4, so we can leave it as that. At the top, we can just leave it as square root of 17, and don't forget the plus or minus. Now bring the 3/4 to the other side, becomes positive. So our answers are positive 3 over 4 plus square root of 17 over 4, or 3/4 over 4 minus square root of 17 over 4. Or you can join them together and write it like so. Example 3. Find the coordinates of the vertex by completing the square and hence sketch the graph of y equals minus 4x squared plus 8x minus 2. So we have to find the coordinates of the vertex. So to do so, we're going to convert this form, standard form, into turning point form. So let's do that. So there's a 2 there, so let's divide by 2 first. And we might as well take the negative out to make it easier for us to look at. So we have minus 2 times 1 is x squared. Sorry, we take the minus 2 out of minus 2x squared. We're left with x squared. That divided by minus 2 is minus 2x. Be very careful with the negative. The minus 10 divided by minus 2 is positive 5. Remember, negative makes up positive. Now we complete the square for that part. So dividing that by 2, which is thus 1. And whatever we add, we have to subtract. So we don't change the question. So now these 3 terms become our perfect square. And then minus 1 and the plus 5 becomes plus 4. And then now we have to take that outside bracket off. Keep your brackets really carefully so that you don't forget to multiply the minus 2 with the 4. It's a very common mistake. So now we multiply the minus 2 and the 4, we get minus 8. And notice I've now gotten rid of that outside bracket. So now we have this in turning point form. We can see it's a negative graph, dilated by 2, moved to the right by 1 and down by 8. Or in other words, the turning point or vertex is 1 and negative 8. So the vertex is 1 and negative 8 and the axis of symmetry is x equals to 1. The y-intercept, we can work that out by substituting x equals 0 in there. 1 squared is 1 times minus 2 is minus 2. Minus 2 minus 8 is minus 10. Since it's a negative graph, below the x-axis, there are no x-intercepts. So try to visualize these. Now let's sketch that. Negative, turning point there, the y-intercept, and because it's pointing downwards, we have no x-intercepts to worry about. Now, is there a way to find the axis of symmetry, which is that value there, see, 1, from the standard equation? Let's figure it out by substituting the standard equation with a, b, and c. Now, if we had a, b, and c, like in the previous example, what do? We took the a out. Now we're left with b over a and c over a. And then we completed the square by dividing by 2. So b over a divided by 2 is b over 2a. And then squaring it, which means b squared over 2 squared is 4a squared. And whatever you add, you have to subtract. But we're not too worried about that. Remember, we're looking for the value inside the bracket to give us the axis of symmetry. So now these 3 values we worry about. So you can simplify that in your own time. But we can see that this perfect square is b over 2a. Now it's plus b over 2a. So our axis of symmetry is minus b over 2a. Last example, use the axis of symmetry to find the turning point of this equation and express the equation in turning point form. So the axis of symmetry is that. So we have to find what a, b, and c are. So that's our a, minus 2, our b is 12, and our c is negative 7. So our axis of symmetry is by replacing that equation with the a and b there. So let's write that out, minus b over 2a. Now b is 12. And a is negative 2. Simplify that. We have 12 over minus is positive 4. 12 divided by 4 is 3. So our axis of symmetry is 3. Now, if you know that the axis of symmetry is 3, how do you find out the turning point? You substitute that into the original equation. So let's find that out. So plug 3 everywhere you see x. So 3 squared is 9. 12 times 3 and minus 7. So into that equation there. So now minus 2 times 9 is minus 18. 12 times 3 is 36. And then minus 7. So we have 11. So our turning point is 3 and 11. Now that we have the turning point and we know the dilation factor is minus 2, we can write it in turning point form. That's it from me today. Thank you for watching. You might want to try this example again, and don't forget to memorize this. The axis of symmetry is x equals minus b over 2a. Memorize that. I'll ask you next time I see you. Okay.